Hello folks, and welcome to the second to last day of Advent of Code. This has been a interesting 2020 for sure, and I am excited to see what puzzles we have in store from Eric for the last 2 days. I am expecting this one to be a little bit of a challenge because it is a night of a holiday. And I am also expecting it to be a lot of fun. So with that, let's go ahead and flip over to my desktop. And let's also have a look at the map. So there's the sea monster. Looks like we're about to land on the island. So we'll see what's on the island. What is happening with the resort that we were supposed to enjoy a vacation, having not needed to save Christmas. Hello, Chico Codes. I hope you're having a good day. My day was a little bit marred by the fact that I mentioned that I think about a week ago I took my main PC down for repairs, and it failed to boot up with the new motherboard. And I have been stuck in motherboard RMA and replacement hell since then. But I'm really glad that this trusty ARM64 board has been serving me well with the streaming and the coding. Actually, it was a thing that I was a little bit nervous about, streaming from this box, but it seems to be holding up pretty well, even when I'm at the same time running a compute-heavy problem. So, one thing that we haven't had this year yet is a maze exploration or anything that involves needing to do an A-star search. So I am imagining that A-star is going to be on the menu for today's problem. If I had to guess, kind of what main theme have we not seen yet this year? We have not seen kind of maze searching problem space exploration. We've only seen relatively procedural stuff. Yesterday was fun because we got to explore either doubly linked lists / rings, or in my case, just using the Golang ring class. Oh, the other thing that I wanted to mention, hey, good luck to you, Vincent. So the other thing I wanted to mention is last night I was realizing while I was talking to my spouse that over here, when I have the cache, I am using a hash map for the cache, and it turns out that this could just be a straight array access. We know exactly how many elements are in here, so at some point I'll tidy that up, but I don't really feel a need to go over it on stream. Just, mentioning that, hey, I found a little thing that was not quite optimal yesterday. Cool. So yeah, we've got a minute before the puzzle unlocks, and I'm pretty excited. Thank you all for cheering me on. Thank you all for helping me this year. It was super fun doing this with a community. Awesome. Yeah, basically waiting the 20 seconds to tick down, and then we'll see what we have. I hope people have good, safe plans to stay at home and celebrate holidays together without crossing across household boundaries. I know that I will be hanging out here with my spouse and doing a video conference with some of the people that I care about, and maybe cooking food on video conference together. Ah, yep, tile floor. Okay, tiles get flipped. How many? Okay, no, this is not a problem. This is not a maze exploration. List of tiles that needs to be flipped over. Oh, but they're hex tiles. Ah, clever. Okay, I know how to handle this. So let's put this in. Wait, does this parse unambiguously? So if I see a S and an O, yep, because SE is a valid token, but S is not a valid token. So if it starts with S, then I have to chomp the next character. Okay, that part's going to be a little bit annoying, but we'll roll with it. We'll roll with it. All right. So let's first of all, tails might be flipped more than once. All right. So So we have the standard coordinate class, and we're just going to need to slightly adjust it to deal with having a minor zigzag to the hex tile pattern. But that's nothing that can't be dealt with. We just need to consider there to be an offset always. Okay. So every tile always starts with the white side up. So how many tiles are left with the black side up? So if we flip a tile, yep. So we'll have just a list of black tiles, and yeah, okay. So S. We need to manually control this iteration. That's super important. S of I. So case N. So north and south are N-ambiguous, but if it's east or west, then we need to, wait, no. East and west are N-ambiguous, but north and south are not. So east and west. Okay. So this is so we've defined the current tile. Oh, so it's actually the reference tile always gets listed here. All right, and at the end of this here, if black current then delete black current, else black current is true. And then at the end of this, length black, so that's all straightforward. So yeah, the way that the coordinates work is pretty straightforward. So the way that it works is that northeast, so let's see. Let me see if I can demonstrate this. So see if I can make this look something like it needs to. So for instance, this is going to be this becomes that. I think something like this is how the coordinate system works. So every set of coordinates is just slightly warped, is how I've seen this before. Okay, so in case east, then we just have current.x minus minus. If we have west, then current.y of x plus plus. And then, let's see. All right, and finally we need a default to say, hey, we don't understand what's going on here. that's just going to be S for now. All right. So, yep. And then we increment that, saying that we've chomped an extra one. Okay. So here, if I go north, east, I'm just thinking about this. Is this the correct way, or do I operate with slanted? I think I actually operate slanted. So I think this is 0, -1. This is 1, -1. Okay, that makes better sense to me. So this is going to be 1, 1. Okay, I believe this better now, because this is actually a consistent coordinate plane. Okay. So if we go northeast, then we are going to increment x, but not, or we're going to increment y, but not x. And if we have northwest, then x minus minus and y plus plus. Okay, I think that does that. So now we apply the same logic to southeast and southwest. So if we go southwest, then current dot y minus minus. Then if we go southeast, y minus minus and x minus minus, I believe. Southeast. Southeast means x goes up and y goes down. X goes up and y goes down. Okay. Check this. Northeast, y plus plus. Northwest. Then, yep. Okay. I believe that. So I think that code should just work. Just plug that in. That's not correct. Okay. Let me run on this example and just check that real fast. So that returns 18, and it should return 10. We're not having any parse failures. Let me just make sure that this scheme is self-consistent. So if I go east 1, and then I go north, if I go east 1, and then I go northwest, what happens? East 1, oh, I have this backwards. That's why. That's probably literally my mistake. Okay, that's now correct. Oh, that feels bad. Okay. 266. That's correct. Rank 329, not bad. So it depends. Have you ever seen hex coordinates or not? Simultaneously to every tile, yep. Oh, this feels like a repeat of the previous day. I do not like this. Alright. Fine. Fine, we'll do it. The only change I need to make here is I'm going to abstract this into a function because I think that makes this easier. You know what? It's fine. So we'll go ahead and fill this in. So we need to have, each one has 6 neighbors. So we have cx plus 1 cy, x minus 1 cy, c x cy plus 1, cx cy minus 1, and then the crosses, cx plus 1 cy minus 1, and cx minus 1 cy plus 1. Okay. And now we also need so we just need a black, which is one of these. Okay. A white tile with exactly 2 black tiles immediately adjacent to it. Yeah, I can basically steal this same logic. Okay. So let's go for this now. So day 0 up to day 100, and then same deal here. So now we execute the logic. Working set make map of chord bool. Working set of t is true, and then same thing as before, for each neighbor. T neighbors. We did this, I forget which day it was, but it had a very similar, the Conway's Game of Life problem is very, very similar. This is essentially the Conway game, except for in 2D, just for the hex grid, so it's not really that much more difficult. Working set of n, not found. Then working set of n is false. So I think that should do it, and it will not overwrite a true value that has been found already. Okay, now, all right, for n in range working set, and finally black equals if so, neighbor count is So neighbor count is 0 for n in range neighbors. If n if black n, then neighbor count plus plus. Oh. Okay, so if black, then if neighbor count, okay, if neighbor count is 0, or gotta mind our or not Omdal's law, whatchamacallem, the thing with the Boolean coordinates. So if neighbor count is 0, or neighbor count is greater than 2, then next of t is going to be false. Oh, then we don't do anything. Okay, now we got to think about this carefully. So if neighbor count is exactly 1, then it stays black. Okay. If neighbor count is 2, then next of t is true. Okay, that should do it. Let's run on my sample. Rolled are applied simultaneously. 6 shells directly touching. $699 does not appear anywhere in there, so I've got a bug. Okay, well, that's fair enough. X, y plus 1, x, y minus 1, x plus 1, y minus 1, x minus 1, y plus 1. Okay. So, what's our bug here? If it is black, then the neighbor count is any black tile with 0 or more than 2. More than 2, not more than or equal to 2. Okay. There we go. Okay, now that's correct, 2208. So now we run it on my real input. We get 3627. And that's correct, rank 264. Okay, that was clean and simple. We wrapped that up pretty nicely. All right. So I'm just going to put this above the chord struct so that we describe it. Chord is a 2-axis representation of the hex grid. Okay. I think all of that is pretty straightforward. what is this code here doing? Oh, because we're flipping them on and off according to the initials thing. Yep, that's correct. All right, yeah, this felt like a pretty clean repeat of the previous problem, just with 2 dimensions in hex. I'll just go ahead and push this up to GitHub. And let's see what the thing looks like. Let's also read the flavor text, because I didn't actually read the flavor text very carefully. Oh, the crab helped us navigate to the island. Okay, so we are finally at the check-in desk, and we're expected to pay for the thing with 50 stars, which we don't have yet, but I expect they'll discount it by 1 star. All right. With that, I'll go ahead and hand over the channel to someone else. Let's hand it over to VWoo, and I will see you all tomorrow for the last day. Cheers.